Hello everyone, welcome back. In this series, we will be discussing about service discovery. In this module, we will be discussing about service discovery. What is service discovery? Why service discovery is important? And what are the different types of service discoveries? We can achieve this using server-side discovery and client-side discovery. And finally, we will use the Eureka server as an example, which we have implemented in Spring Boot 3.0 with microservices. Service discovery is a critical aspect of microservices architecture. Service discovery is a fundamental concept in computer networking and distributed systems, particularly in context of cloud computing, microservices, and containerization. It is the process by which individual services within a distributed system or microservices ecosystem dynamically locate and communicate with each other. In simple terms, service discovery allows microservices to find and interact with one another without requiring a fixed hard-coded list of IP addresses or host names. Instead, services are registered and can be discovered on the fly as they come and go. Service discovery is crucial for enabling the dynamic and automatic connection of various services and applications within a system. Let's discuss more about the overview of service discovery. First, we will discuss about the purpose. What is the purpose? Why we want the service discovery? Service discovery simplifies the management and scaling of distributed system. How it enables this? By allowing components to find and interact with each other without manual configuration. It is essential for load balancing, failover, and seamless communication among the services. Distributed systems. In distributed systems, services or component can be running on various servers, containers, or virtual machines. Service discovery helps locate these services dynamically, irrespective of their physical location or IP addresses. Now let's discuss some of the use cases for service discovery. It is commonly used in microservices architectures, container orchestration platforms like Kubernetes, and cloud environments. It's also valuable for IoT networks where devices needs to discover and communicate with each other. In service discovery, there is one important concept called as service registries. Service discovery typically involves the use of service registries, which are database or directories that maintain information about available services. These registries store service metadata such as service names, address, and their health status. Now the next question comes, how does it works? So when a service starts, it registers itself with the service registry, providing information about its location and capabilities. Other services can query the registry to find the services they need. This allows for dynamic and automatic service to service communication. The another important aspect in service discovery is load balancing. Service discovery is often used in communication with load balancers. Load balancers can distribute incoming traffic across multiple instances of a service, ensuring even distribution and high availability. Health checking. Service discovery system may include health checking mechanism to monitor the status of services. Unhealthy services can be automatically removed from the registry, ensuring that only healthy services are used. Service discovery protocols. Various protocols and tools facilitate service discovery, including DNS-based service discovery, console, etc., and tools provided by container orchestration platforms like Kubernetes. So let's summarize it. Service discovery is a critical component of modern distributed system, enabling automatic and dynamic communication between services and resources. It simplifies the management of complex architecture and contributes to the flexibility and scalability of these systems. Server-based discovery and client-based discovery are two approaches to service discovery in distributed system. They differ in terms of where the responsibility for service discovery lies. Let's understand more about server-side discovery. In server-based discovery, the responsibility for service discovery primarily resides with the server or the service provider. The server advertises its presence and capabilities to a central service registry, typically when it starts up, and the registry maintains a list of available services. Client or service consumers query the registry to discover services they needed. The key characteristics of server-based discovery are: first, services registers themselves with a central registry. Then the client requests information about the available services from this registry. The registry is typically responsible for load balancing and health checks. Example of server-based discovery tools include Console, Eureka, etc. This approach is common in microservices architectures, container orchestration, platforms like Kubernetes, and cloud environments, where services are numerous, dynamic, and need to be discovered by multiple clients. Now let's focus on client-based discovery. In client-based discovery, the responsibility of service discovery primarily falls on the client or service consumer. The client knows the location or the endpoint of the service it wants to communicate with and is responsible for resolving the service location without relying on central registry. This resolution can be done through various mechanisms such as DNS, configuration files, or environment variables. The key characteristics of client-based discovery are: clients are aware of service location or endpoint. Clients directly contact with the service without querying a central registry. Service location may be specified through configuration or dynamic updates. This approach is often used in scenarios where services are more static or where the client has prior knowledge of the service location. Client-based discovery is simpler in some cases and can be effective when the service's location is reliably stable. However, it may not be as suitable for highly dynamic and large-scale distributed systems. Both server-based and client-based discovery have their own use cases and advantages. Server-based discovery is well suited for scenarios with a high degree of dynamism and where services need to be automatically discovered by multiple clients. While client-based discovery is appropriate when services are more static or when clients can effectively manage services endpoint without relying on central registry. The choice between these approaches depends on the specific requirement of distributed system. Now let's see some more insight about the Eureka Server. Eureka Server is an integral part of Netflix suite of tools designed to support their internal cloud-based architectures. It is developed by Netflix. Eureka plays a critical role in the microservices ecosystem, which supports large-scale, resilient, and distributed systems. The primary purpose of Eureka Server is to manage the process of service discovery. In a microservices architecture, managing numerous services and ensuring they can find and communicate with each other efficiently is very important. Eureka Server provides a robust and scalable platform that enables services to register themselves, maintain their status, and discover other services within the ecosystem. Now at high level we will discuss about how it works. The first step is service registration. When a microservice starts, it registers itself with the Eureka server, typically providing metadata such as its IP address, port version, and health indicators. This registration process allows the services to be discoverable within the network. The next step is heartbeat mechanism. To maintain the accuracy of service list, each registered service periodically sends a heartbeat signal to the Eureka server. This heartbeat confirms that the service is still operational and maintains its registered status. If the service does not receive a heartbeat within a predefined interval, it removes this service from the registry, assuming it has crashed or it is no longer reachable. Then the next step is service discovery. When a microservice needs to communicate with another service, it asks Eureka Server for available instance of that service. The Eureka server then returns a list of available service instances within their metadata. The client service can use this information to make an informed decision about which instance to call, often incorporating load balancing. And the final one is self-preservation and reliability. One of the critical features of Eureka Server is self-preservation mode. This mode is designed to prevent the Eureka Server from indiscriminately removing instances when there is a network problem between microservices and as the Eureka Server as opposed to actual service failures. This helps in avoiding the cascading failures of services across the architecture. We have been seeing this diagram in our several videos where our flight booking system is composed of several services like booking service, flight search service, payment service and notification service, right? These services are tied together through an API gateway which acts as a single point of entry point for the front end, directing client requests to appropriate services. The Eureka server is a service registry that enables these services to discover each other. Now let's discuss about registration with Eureka. Each microservice when it comes online register itself with Eureka server. This typically involves configuring the application properties in a Spring Boot service with Eureka client properties. For example, consider the case of booking service. So here for this booking service we have application.properties file, right? So here we can provide this information. Like once we have this application name as booking service, we have to provide here Eureka information like eureka.client.service url.default zone, which will configure this URL for Eureka server. By default, the Eureka server will run on port number 8761. The next we will discuss about discovery process. When the flight search service for example needs to communicate with flight service, it does not know the exact location, for example IP and port of the flight service. Instead, it uses Spring Cloud Discovery Client or load balance REST template to ask the Eureka server for the instance of flight service. Eureka then returns the available instances and the flight search service can make a call to call them. We will see the demo of same in the next video. Let's discuss some of the benefits of Eureka. The first one is load balancing. When multiple instances of services are registered with Eureka, it provides a client-side load balancing by giving out different instances to different clients requesting with same service. Easy scaling. Services can be scaled up or down and the new instances can be added or removed without direct intervention or reconfiguration of clients. Resilience. Eureka Server is built to be resilient to failure. With its self-preservation mode, it can prevent the registry from rapidly changing in case of network issues. Service discovery. It allows services to discover each other dynamically using logical names rather than hard-coded network location, which facilitate easy communication and flexibility. And this is the dashboard for Eureka Server where we can see all our services, how they are registered. In our next video, we can see in more detail about the demo, how we can configure the discovery server and how we can configure each services to call other services. In the previous video, we have discussed about the concept of inter-process communication within our microservices. Specifically, we examine how booking services will communicate with flight services using the FAIN client. We made the direct call to the flight service by hardcoding URL to localhost 8082/v1/API/flights. While this approach works in our local development environment, it possesses challenges in the cloud-based microservices setup. In a cloud environment, we cannot rely on dedicated IP addresses. Everything becomes dynamic, including IP addresses and the port numbers. Flight services will be available in this IP addresses, right? In addition to that, we can have multiple instances of a given microservices. Like in this diagram, you can see we have multiple instances of flight service, and each instance can have a dynamic IP address. For example, you can see one flight instance can be 10.0.0.1, the another one can be 10.0.0.2, and the next one is 10.0.0.3. Now in this instance, how our booking service will know which instance of flight service we have to call, right? It cannot understand which instance we have to call, and even though we tried to hard code one instance of IP address of one instance, if it can have instance that go down anytime, right? It can be stopped or shut down anytime, and we have to make a call to another instance. So how do our booking service understand which flight service we have to call? For this reason, there is a patent called as service discovery patent, and we are going to discuss the same about this in our video. We have discussed at high level about what is service discovery, what is service registry, and what are the different labels like client service registry and the server side registry, right? Now let's discuss more for same. So service discovery pattern is nothing but creating a server called as discovery server, which will store all the information about this services such as booking service, flight search service, flight services, and so on. And all this information are stored such as flight service name, their IP addresses, etc. Now let's consider the case of microservices. For microservices, let's say for discovery server we are using the Eureka server. So what happen when the microservices pattern will start? First it will do is it will create a discovery server, which is a place where all the informations related to services are available, right? And then it will store all this information in a service registry, one at the time of starting of the application, and then we'll try to register with discovery server, making them a request. So for example, if you see in this picture the booking service, it will try to ask like where can I find the service, right? Which service he wants to communicate with flight service. So it is asking this question with discovery server, and discovery server is responsible for providing the details of flight service. And once this information is provided by discovery server, then booking service will communicate with flight server using this appropriate method. Now let's discuss something more about client's local copy of service discovery. So whenever the services are making the request, it will add the discovery server, will add the entries of the service into its local copy. We call it as registry. So that's why it is called as service registry. Once all this information is available in discovery service, whenever they wants to, for example, booking service wants to communicate with flight service, what they will do, they will ask the discovery server, and the discovery server will call the client, will have a local copy of this registry inside this booking service. That's why we can see this information here.